What you're about to hear is part 2 of a 3-part audio slidecast documenting a conversation between Debra Pothier, a senior education AEC marketing manager for Autodesk, Dave Fano, a professor with the architecture department at Columbia University, and some of his students who participated in a special design to fabrication workshop Professor Fano and his colleague Joshua Emig developed for the students. For Debra's conversation with Professor Fano, please listen to part 1. Part 2 opens with Debra talking to students Chris Powers, Joe Wangbo, and Ben Carr about their experiences with the workshop. In this opening segment, Debra asks Chris to introduce himself, describe the design to fabrication class, and then discuss his team's specific design.
Thank you very much. My name is Christopher Powers, and I'm a first-year graduate student at the University of Columbia. The class that we took was a class on orchestration. It really focused on the links between the fabrication of a specific unit, specifically a curtain wall here, and the design that goes into that. And basically what we did is we chose an existing building, an unbuilt work in Switzerland by Zaha Hadid, and we designed our own envelope to encompass that design. And the envelope, the specific building that we chose was a particular envelope that went around several existing buildings. And so we really kind of wanted to pick up this idea of flow and curtain wall from this design, and what is a curtain wall, and how do you kind of emulate that design in both the sense of the word and also the design. So we came up with the idea of this copper ribbon system that would be almost like a metal waterfall that would clad the exterior of this building. And by using copper, we are going to allow the material to change over time and have that water and wind and air really kind of inflect on the surface itself and change it in a very dynamic and interesting way. The other complications or actual interest that we had in this building is in the particular wall segment that we chose it led into a theater space. And so it was a single vault, 30-foot space on the interior that allowed the viewing of the wall both from the interior of the building and also from the exterior. So we had this really interesting dynamic between the interior and exterior of the building, and so we had to really design both sides. So what we did is basically we started off our design in quick preliminary in Revit to really kind of get a feel for what the modulation would be like, how many of these units would go up, what would be good spacing between floors, because as I said before, we had a 30-foot space. We didn't have floor slabs that kind of delineate where the spacing was between these kind of segmentation to it. So by using Revit, we were really able to kind of very clearly mark out a very early design, very simple, but was able to parameterize it so that we could change it multiple times, multiple iterations without actually having to go through and start over from scratch. That really led quite well into our use of Inventor, and really Inventor was the mode that we used to really kind of finite and hammer out the details on a lot of the connecting materials and how this thing really went together. And Inventor itself was actually quite an interesting program because of its intuitive nature. It allowed you to work from sketches to extrusions and so forth, and really kind of gave us a feel for how this was going to be put together in the fabrication sense. Specifically, the sheet metal ability of the software with these copper ribbons was extremely beneficial, because we have these very complex curves and bends that were going to be incorporated into the design that really, I mean, the logistics of having to do that on just like paper would be almost impossible to figure out. So it really allowed us to kind of hammer out these very fine details, and also again, we were parameterizing it as we went, so it was able to change the design quickly to adapt it to what we really needed it to do, and really just come out with a very fine and finished design in a very short period of time, and yet allow enough space, enough manipulation, and enough room so that when we actually go to fabrication, hopefully the idea is that the design will be manipulated in a very smaller sense and be able to continue that design without having to start over or redo drawings or such. So that's really how we came up with the pattern and design overall, and the use of the programs was quite unique.
In the next segment, Chris responds to Debra's request that he comment about his experience using Autodesk Inventor software in the work his team did in the Design to Fabrication class.
And what we were able to do in Inventor was to take out those geometries by using the 2D sketch, formation of the things. We were able to really quickly come out with the shapes that we were looking for, and in terms of the structure we needed and the overall design we needed. And then we were able to manipulate it using parameterization of certain aspects and dimensions and such to really kind of manipulate that very preliminary shape into an ergonomic design, into a very efficient design, into maybe a more elaborate design than we were looking for, to have kind of that visual interest involved in it. And it really kind of, at least on my part, it gave me a very intuitive sense of, a lot of these programs are so separated in terms of, like, AutoCAD is 2D, 3D Max is 3D, but the Inventor really kind of incorporates both aspects of it in an almost streamlined fashion because of the way that you draw a 2D sketch and then you extrude it or you loft it, and then from there you would remove material and so forth using bolt holes or whatever the case was. So it almost gave me a sense of building this material in the modeling space as well as in my mind. And so I think it gave me a much more concise idea on how this thing's actually going to be built, because you'd extrude a solid form, you'd remove material from that form just like you would CNC mill a piece out. And so it was really interesting in that sense. And one of the other great aspects I like about this program was the formation of the CD set itself. The ability to just drop these drawings into a paper space is just incredible and speeds up the process so much. And more importantly, because it's dropped in directly from model space, any changes that you make to that model are automatically updated in the space. And that's pretty much consistent with Revit and Inventor, and one of my favorite aspects of the programs. I spent so many years redlining CD sets that to be able to do it almost seamlessly is a fantastic little invention there. So that was great.
In the next segment, student Joe Huangbo responds to Debra's request for him to provide a brief description of his team's project and case study for the Design to Fabrication class, and in specific, to highlight the source of inspiration for their design.
Sure. Basically, for our case study, we looked at, we also looked around and we found an architect firm in France called Serrero Architects, and they had been doing this sort of canopy enclosure system where the apertures of the envelope are very kind of organic and sort of very almost random in certain like size, scale, and form. And we were really interested in that and trying to achieve the same sort of sensibilities, but we also wanted to take into account that this was something that could be mass-produced at a very low cost, but still, yield the same results and not some of the monotony that I think is kind of present in those, I guess, projects with those kinds of goals, I think, especially nowadays. And so basically we looked at the same thing that they looked at for inspiration, which was trees and canopies and exactly like aperture in terms of how light filters through trees and their branches and their leaves. And we looked at that patterning system, and we kind of translated that directly into the actual system that we were going to use to put on the building. And basically that kind of evolved, and we came up with a system that you could, just with one cast, you can basically make this unit that is, if you just rotate it just kind of randomly, you come up with a very variated pattern that does not repeat at all, actually. And so that's kind of what our design intent was, and I think that's kind of what we tried to achieve.
For more information, visit www.autodesk.com/edcommunity.